what's going to be called an ellipse. And ellipse is another form of a conic section. Traditionally, we would go parabolas, circles, ellipse, hyperbolas, but I figured that ellipses take a little bit more time, a little bit more stuff going in there, and the fact that I know you've done circles before, you did that last year, those will be really easy. That way tomorrow we'll be able to give back all the tests, go over a couple of things that I found, and then do circles, and we'll be done early, and you guys probably won't have to worry about too much. You'll probably be done with everything out of here. That's kind of my plan on this one. It worked out nicely. So the easiest thing that I've done before with in terms of an ellipse is to kind of show you guys what exactly happens and how they occur. An ellipse is a set of points that are all equidistant from they're equidistant. A plus B, the distance from any point remains constant to the two foci within. So obviously you think of an ellipse, you think of an oval. Okay. So when you have these ovals or ellipses, if you will, they still have vertices. They have vertices that will be placed here and here, so there's still, that vertex still looks towards the focus. That always happens. Now, they have what are called vertices, and then they have what are called co-vertices. Co-vertices and vertices, they meet at the center. Okay. Now, the center of these things are still going to be located today at the origin. Eventually, we'll shift them and move them, and how we find these distances, it is super, super easy. But yeah, just remember that they just remain this distance, the sum of the distances to the edges remain constant. It's kind of cool. Yeah. Anywho, ellipses have two separate. Well, actually, we do this. Ellipses wind up with two types. Get one like here. It's one. Is that we have two forms of an equation. We have x squared over a squared plus y squared over b squared. Excuse me. I think they say it equals 1. Double check that. About a year. Yes. And then you have x squared over b squared plus y squared over a squared equals 1. There are two forms of an ellipse. What's the difference between those two formulas? Pretty obvious. Where b and a are. Everybody see that? Now, the a squared value is always greater than the b squared value. So whatever number you have, for example, if you have, this is 9 and this is 4, that means 9 is playing the role of a squared. If this is 9 and this is 12, that means 12 is playing the role of a squared. Right? That's where this comes in. That's how you're able to decipher which one is which. The a squared value is always the larger of the two numbers. And the a squared value is always the largest of the two numbers. This in turn allows you to figure out what direction the ellipses are stretched. Just like with parabolas. Parabolas, we had them up like a cup, down like a frown, right like a kite, or left like theft. It's gone. They thought of that in the 11th hour. I liked it. Because negative, when you get theft, it's negative, something's being taken away. Left like theft. I'm using something better. Go away, we're trying to learn something. I can't. So what happens here is you get stretched one direction versus the other. Okay? By understanding where your a value is, which one is the a squared term, which one is larger, it shows you which way things are stretched. And I think we talked a little bit about this on Tuesday when I showed you guys that apps button in the calculator. When you have your, excuse me, when you look at the ellipse picture, see, I know right now there's h's and k's, and that's just shifting. We'll talk about that next week, so don't worry about that right now. But if you notice, a squared is underneath the x. When it's the larger value is underneath the x squared term, it's stretched left and right. And when it's underneath the y value, it's stretched vertically. That's how you're able to tell where your major and your minor Not too terrible. Let's plot out where things are going to look like. So for today, we're centering everything at an origin. We're going to center everything at an origin. Let me show you guys how this is going to work. Everything's going to be centered at the origin today. So if you are, whenever you have an a squared, the larger of the two underneath the x, on the x side, what I want you guys to do right away, as soon as you notice that, draw a little picture that's being stretched right and left. That way you'll remember that your vertices go left and right. Your co-vertices will go right. This value of a is the distance. Notice it's not a squared. It's a. So it'll take square roots here. Is the distance from the center to the vertex. I'm just going to make it like this for right now. I'm going to call this a. I'm just making up numbers as I'm going, okay, guys? Just to kind of give you guys a visual of what it's going to look like. The a value is always the distance from the center to the vertex. The b value is the distance from the center to what we call a co-vertex. A co-vertex is, well, sometimes you'll hear them worded as what's called a major and a minor axis. The major axis means it's being pulled, for this one, it's being pulled left and right. The minor axis is the up and down part. So the distance from the center to the co-vertex should be smaller than it is to the opposite of B, positive. Bless you. And then we get that. Now, what's nice about ellipses is that they're really, really easy to draw. Because all you're going to be doing is you're going to be plotting points. And more often than not, our point values are going to be all usually nice, perfect squares. 2, 4, well, I'm sorry. Our a squareds and b squareds are usually 1, 4, 9, 16s, 25s. You'll get a 12 here or there, but it's not too common because all you're doing is just rough guessing and labeling points. And as we get into actual numerical values, you'll see how easy this stuff is. When you do this, we're missing, we have a vertex, a co-vertex. So these guys are, this is a vertex here, here's a vertex. This is a co-vertex. This is another co-vertex. What we're missing is our foci, excuse me. Because there's 2 vertices, that means there are 2 foci. And remember, the vertice always looks at its focus, just like we did with parabolas. Every time the vertex looks at a focus. So here's how we have to figure that out. In order for us to figure out a focus, we call the focus value, the c squared will be our focus. The value of the distance from the center to the focus is found by a squared minus b squared. And then in which that takes the square root. Okay. So this value of c will be the distance from the center to the focus. All right. Once we throw some numbers in it, it gets really easy because if you do this correctly, then when you look at your ordered pairs, your value of C will be somewhere inside. That focus would be inside the oval, inside the ellipse itself. And that's how all of our parts are going to wind up doing. And it looks kind of like a lemon head as you get into it. Okay. It looks exactly the same when it is the y squared has the a squared underneath it. When it's stretched vertically, all of these values are exactly the same. If you just turn your head sideways, that's what it would look like. you like to look at some numbers, see how this works? Pretty quick. Okay. Dude, one second. People are feverishly finishing up. Okay. So really easy with this stuff is to start with an example. And I'm going to draw the ellipse given by the equation. And I'm going to identify all of the parts. I'm going to jump right into an example that you have to do a couple of steps with. Now, we have two formulas. We have two formulas for the equation of an ellipse, one of which is the x squared over the a squared plus y squared over the b squared equals 1. What direction is that one stretched? Horizontally, left and right. Okay. And the other version is the x squared over b squared, y squared over a squared is 1, and this one's stretched vertically. A is your distance from center to vertex. B, distance from center to co-vertex. And then C would be the distance from, oops, I can spell the word from, center to focus. To get C, you do that. Now here's a little thing that'll happen. We have to talk about, we have ellipses and then we have hyperbolas. Hyperbolas look like ellipses in terms of their equations, but hyperbolas have a subtraction between the two, and then they would have a plus between the two. So if you start forgetting when we get into how do you find C values for hyperbolas versus foci, is that if the generic form of the equation has a plus in it for an ellipse, to find C has a minus. And then when the generic formula of a hyperbola has a subtraction, to find C has a plus. You correlate that between the remembering it, because I won't give you this stuff. I'll let you have formulas for these things. I'm not going to make you memorize it. Whether I just let you use your calculator because it's in there, or just give you a little sheet, it doesn't matter. But I will not give you this stuff. Is that fair? So to get into one of those forms, what do I have to do first? And it's not subtract 143. Thank you. If I got to get one side equal to 1, what do I do again? Nope. No. Well, I have to do what? I got to get one side equal to 1. What do I do to get that equal to 1? Divide by 144. Divide everything by 144. This is a very common thing. When you divide everything by 144, obviously 144 divided by 144 is 1. Now watch what happens here. It equals 1. 16 over 144 is 1/9. And what do you think 9 over 144 is? If one of them is 1/9, the other one's going to be a 16. So you wind up with that first step. This is super common for that to happen, where you have to divide out by whatever's on the side. Okay? It's very, very common. So now you've got your formula, your generic form, x squared over 16 plus y squared over 9 is 1. Which way is this stretched? Left and right or up and down? Left and right. It's left and right because 16 is larger than 9. So that we know this goes like that. And here's how I do this stuff. Once I know that my center is located at 0, 0. Because there's no h, there's no k. We're not worrying about that stuff yet. Okay. I know that my a squared value is how much? 16, okay. I know my b squared value is 9, and then I know that c squared will equal 16 minus 9. Okay. So if a squared is 16, that means a is how much? 4. -4. So I'm going to say my A value is plus or minus 4. Reason why I'm going to start making sure I do those plus minuses is because eventually, when we start shifting things around, if I've got a vertex at 3, -2, I know I'd have to move something left and right. I know I have to add and subtract values to X and Y coordinates. Okay? Same thing with B. My B value will equal plus or minus 3. My C squared value is 7. So my C value is plus or minus root 7. Okay? Don't need a decimal. We won't use any decimals. And usually the C value is the one that gets maybe a little bit for the root stuff. Okay? Was that bad? No, it's just very simple. It's just, but now we're understanding where things are going to go, so we start plotting this. Center's at the origin. The A value, excuse me, my A value is center to vertex. Let me do this. I have a center, I have a vertex. There are 2 ordered pairs that I need to list for my vertex. My covertex has 2 ordered pairs that I need to list. And my foci, there are 2 ordered pairs that I have to list for that. I'm just making a running tally of the 4 points I'm going to have to identify. I'm sorry, 6 points I have to identify. And then I start drawing it. Center's at the origin. Distance from the center to the vertex is A. So I go left and right, 4. Those ordered pairs then are 4, 0, -4, 0. Every time I plot a point, I'm going to write down the ordered pair. Okay? Just to keep tabs on things. I do it again. Covertex is distance from the center to the B value, which is the distance from the center to the covertex, and that was up and down 3. So that's at 0, 3, 0, -3. So far, so good? Square root of 7. Square root of 7, bless you, is more than the square root of 4, but less than the square root of 9. You guys okay with that? I'm doing an approximation here. So 3.5-ish. Sound close-ish? I'm at 2.5-ish. Good job, you guys are paying attention. Good work. So if I say 2.5-ish, I can just put a dot here. But when I put that as far as an ordered pair is concerned, I would just write root 7, 0, negative root 7, 0. And I've identified all of my parts. All that's left to draw is the lemon head man. Extremely procedural. What's this? What's this? What's this? Label, label, label. Man. It really is. It really isn't. And honestly, the weird stuff of this comes when you're given. Remember how you guys had you were given the directrix, write the equation of the parabola. You had to figure out what things meant. That's usually the weird part of this as well. You'll be given an ordered pair of a vertex, ordered pair of a focus, and so on. But it's nice that everything's centered at the origin to start. Do another one like that? Yep. We'll do one vertical, then we'll do the ordered pair stuff. So if I start with 25x squared plus 4y squared equals 100, I need to get one side equal to 1, which again means I'm not going to subtract 99. I'm going to divide everything by 100. Okay. As you divide everything by 100, you should be pleasantly surprised that, look at how nice and clean these numbers were. We get x squared over 4 plus y squared over 25 is 1. Which way is it stretched? Vertically. Sketch it. I don't know how many times I've had students not sketch that, and they think it's the same thing as the problem they did previously, and they forget to reference it. And they'll plot everything the wrong way. They'll do it right, but you went the wrong direction. So now you know that your a squared is what? A squared. 25. Yeah, I'm trying not to skip ahead here, because when I do a squared is 25, b squared is 4, c squared will be 25 minus 4, and then you get your a plus or minus 5. Okay. Not a bad idea to list out your vertex. Bless you. Quizzes and tests, I usually write this in here for you to remind you that you need to list them. Where I'll put a bunch of labels of like, hey, what's the vertex? What's the focus? What's that? And that way you remember, oh, I forgot to write that over here. Where is the center? Centered at 0, 0. So the center, 0, 0. Plot your vertex. Which way do you go? Up and down. And that's why you always draw this little rough sketch, because you know whatever direction it's stretched is the direction you go for your vertex. So just go up and down 5. So 0, 5, 0, negative 5, 2. And then the C value. Plus or minus the square root of 21. Again, it's more than 4, less than 5. It's probably closer to 5 than it is 4. So just put it somewhere-ish. It's not an exact science. All you're doing is putting a dot somewhere where it looks like it should be, because the exact portion of it comes here. 0, root 21, 0, negative root 21. That's where it becomes specific once you label it. And what's left to do? Draw the lemon head, but he's bell over. It's actually a pretty good one. That's why I was calling it the lemon head. I mean, it looks like a lemon head. I don't like lemon heads. I had some nerds yesterday for the first time in forever. It wasn't bad. Okay. Procedural. Weirdness happens really when we get into stuff like this. Trying to figure out where things go. And that's where understanding what A, B, and C stand for. By understanding what those values stand for, it's very easy to figure out which of the two you're working with and how to fill in the blanks. Okay. For example, if I look at the first one, I have vertex at 0, 7, co-vertex at negative 6, negative 6 and 0. What do you think I'm going to say that is a very, very, very strong idea to do? Always, 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 guys. So much of this stuff is visual. And the more you can put on a piece of paper to see what's going on, the easier everything becomes. If you know your vertex is at 0, 7, zero, 7 goes up, doesn't it? If my vertex is up there, which way is it stretched? Stretched vertically. So right away, I know this is stretched vertically, and I know that my A value is what? 7. My A value is 7, okay? Which makes A squared 49, okay? Co-vertex went left, so my B value was -6. If I square that, what do you get? 36. Since this is stretched up and down, underneath which value does the 49 go? Underneath what? There you go. You get x squared over 36. Oops. You guys do the next one. -4 and 0 for a vertex. Focus at 2, 0. Give that one a shot. We'll roll through this real quick and see how it did. Vertex is at -4 and 0. So if my vertex went left, that means which way is this going? It's going left and right. Right. You know that if your vertex told you to go to the left, it means it's stretched left and right. So that means your A squared value, your A value is 4. I'm going to negate the negative. If I square that, I get 16. Focus is at, focus is at 2, which means what's your C value? 2. Means my C value is 2, and C squared is 4. Which means we got to figure out what B squared is. So B, we got to figure out. Remember, C squared equals A squared minus B squared. 4 is 16 minus what? So that means your B squared value is 12. Do I need to worry about writing that as 2√3 anymore? No, because all I'm doing here is writing out the formula. I'm just writing out the formula. So that means my B squared value is going to go to is just 12. Excuse me. So it's stretched left and right. So I have an x squared plus y squared. This is over a squared, b squared, 1. So I get x squared over 16, y squared over 12. 1. Yes, ma'am. You don't, but the reason that I do is because when we shift them, it'll make it easier. You know that it's left to right or up and down. If whatever number, wherever a squared is, the a squared value is always the larger of the two numbers. So if here, see how 16 is bigger than 12? That means it's stretched left and right. Since this number is bigger, that's why it's underneath the way that it's stretched. Ellipses are weird like this. Whatever number is bigger for the denominator is the direction it's being shifted. If it's underneath the y, it's going up and down. If it's underneath the x, it's going left and right. There will be different rules for hyperbolas later. Okay. A lot of little bits and pieces here, a lot of little bits and pieces. Those work. Yeah. Every other, yeah, let's do 30 problems tonight, guys. I think that sounds like an awesome idea. You're welcome. Yeah, that's a great idea. Yeah, I can't remember the last time I assigned that many problems, to be honest with you. I think I think when we get into some of the trick stuff, just as far as like review junk is concerned, how that's all goes through with a few days worth, there might be like 30 problems over the course of 2 days. But a lot of that's review, just to get, excuse me, just to get your minds into things going. But then again, Miss Yule will be teaching that stuff, so it's up to her. I'm just gonna go hide and yeah, right. She's gonna like, you guys have to do everything. You think she's nice, but yet all of a sudden she's gonna come in one day and just go, you guys have to do your homework. Okay? I would.